Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss limits and derivatives. Limits and derivatives. In this chapter, we are going to discuss the concepts of exercise 13.1. Concepts of exercise 13.1. Okay, my children, are you ready to listen the class? Right. Come to the first point. Point number 1. Limit of a function at a point. What is meant by limit of a function at a point? Suppose let us take an example to understand this concept clearly. Okay, my children. Let f of x is equal to x plus 1. Okay, my children, we assumed here a function in x as f of x is equal to x plus 1. And we are finding the values of x at 1 or at 2 or at 0 and very near to the 0 on the number line. The numbers very near to 0 or very near to 1 or very near to 2 means we take left side and right side to that particular number. Suppose for example here I am taking the values of x very near to 1. Okay, my children, from left and right side. So 0.9, put 0.9 in f of x. Then what will you get? F of x then f of x 0.9 plus 1, that is 1.9. Isn't it or not, my children? If x is equal to 0.99, then f of x value. What is f of x value? 0.99 plus 1. What will you get here? 1.99. Isn't it or not? Okay, my children, just to be substituted. If x is equal to 0.999, then f of x value 0.999 plus 1. What will get? 1.999. Isn't it or not, my children? Suppose if x is equal to 0.9999, then the value of f of x 0.9999 plus 1, that is 1.9999. Like this we get to the values of x. Here I took the values of x very near to x from left. Okay, but all these numbers are 0.9, 0.99, 0.999, 0.9999. These are all the values from left to the number 1. Now if I take right side, if x is equal to 1.1, I am taking the values of x very near to 1 but from right of that 1. Then f of x is equal to 1.1 plus 1. What will you get here? 2.1. Isn't it or not, my children? If x is equal to 0.01, then f of x 1.01. 1.01 plus 1, what will you get? 2.01. If x is equal to 1.001, then f of x 1.001 plus 1. What will you get? 2.001. If x is equal to 1.0001, then the value of x is equal to 1.0001 plus 1. What will you get here? 2.0001. So if you observe these values of x, when the values of x are very closer, very near to 1, the function, the values of the function is also, see here, what will you get? 1.9, 1.999, 1.999, 1.9999, 2.1, 2.01, 2.001. For which real number the values of f of x is approaching, yes, 2. So where we say that here, as x tends to 1, limit f of x is equal to 2, means as x is approaching, we read it as limit of f of x is 2, or assuming limit of f of x is assuming limit of f of x is 2, or limit of f of x is assuming the value 2 as x is approaching to 1. Okay, my children, understood? So symbolically we write it as limit of f of x is equal to as x tends to 1. Okay, my children, this is the concept of limit of a function at a point. Okay, my children. So here the values of x are taken very near, very closer to the 1 from left side and from right side. If you observe, all the values are very closer to number 2. That is why we say that as x tends to 1, limit of x or limit f of x is equal to 2 as x tends to 1. Understood this point, my dear children? Right. So in general, as x tends to a, read as x is approaching or x is tending, x tends to a, f of x tends to L, f of x is approaching, read as the values of f of x are assuming or approaching to L. Then L is called limit of the function f of x, which is symbolically written as like this. This is a symbol, this is a notation. Okay, my dear children, we read this symbol as limit of f of x as x tends to a is L. Limit of f of x as x tends to a is equal to L. Understood this point, my dear children? Right. Now let us take an example, my dear children, to understand that concept clearly. Let f of x is equal to x square minus 4 by x minus 2, comma x is not equal to 2, because if you take the values of x at 2, then it is not defined. Okay, by my dear children, 0 by 0. If you substitute x is equal to 0. In the numerator we get 0. In the denominator also we get 0. 0 by 0. We get 0 by 0. That form is called indeterminate form. We discuss it later. So compute the values of f of x for the values of x very near to 2 but not yet 2. Understood? But this point, my children, we should not compute the values of x at x is equal to 2 but very near to, means 1.99999 like this. In the previous example I have taken very near to 1. Here also we have to take the values of x very near to 2 from left and from right. Convince yourself that all these values are very near to 4. If you compute the values of this function, when the values are very near to, values of x are very near to 2, the values of f of x also very near to, very closer to 4. This is somewhat strengthened by considering the graph of the function y is equal to f of x given below. See here, my children, this is y is equal to f of x. Graph of y is equal to f of x. At the point 2, here see there, a hole means this denotes that function is not defined at x is equal to 2. Okay, my children. But from this point, if you observe left and from this point right, all these points are approaching, these values are approaching to 4. Very near to 4. So we say that as x tends to 2, as x tends to 2, or as x approaches to 2, limit f of x is equal to 4. Okay, my children, understood? Right. Now come to the next example, my children. See here, in the previous examples we have taken the value which the function should assume at a given point at x is equal to a did not really depend on how is x tending to a. Okay, my children, note that there are essentially two ways x could approach a number from left or from right, x less than or equal to a or greater than or equal to a, either from left or from right. That is, all these values of x near to x could be less than a or could be greater than a. This naturally leads to two limits, namely left hand limit and right hand limit. Right hand limit of a function, right hand limit, this is, suppose if you take this function f of x is equal to 1, x less than or equal to 1, f of x is equal to 2, x greater than 0. Okay, my children, a function f of x is defined like this. In this case, f of x, the function is said to be piecewise defined function. In two different intervals, f of x is defined. If x values are less than or equal to 0, f of x value is 1. If f of x value is greater than 0, f of x is equal to 2. So I represented this function on the number line like this. On the number line here 0, 1, 2, 3, here minus 1, minus 2. Point is 0 here. At the point 0, left, as x is approaching to 0 from left, f of x value is 1. As x is approaching to 0, f of x value is 0. F of x value is 2. F of x is equal to 2. So we have to find, if you want to find the limit of this function as x tends to 0, we have to find the left hand limit as well as right hand limit. So this is a graph of y is equal to f of x for this function. See here, if x is less than or equal to 0, we get this line, and x is greater than 0, we get this line. And to see here, a hole is defined here. because greater than 0. At 0 it is not defined. Okay, my children, right. So in this case we have to find left hand limit as well as right hand limit. So it is symbolically written as extends to 0 minus, as extends to 0 minus means left hand limit of the function f of x as extends to 0, or as x is approaching to 0 from left means left hand limit 0. Okay, minus 0 power minus 1, but we don't read as 0 power minus 1, as x is approaching to 0 from left. F of x is equal to, what is the value? 1. This is called left hand limit. Short form, left hand limit. I wrote in the short form, left hand limit. Right hand limit, as extends to 0 plus, as extends to 0 plus means x values are approaching to 0 from right, this values from right means 0 0.01, 0 0.001, 0 0.00, like this. Understood this point, my children? Here x is taking minus 0.9, minus 0.999, minus 0.1, minus 0.01, minus 0.001, minus 0.0001, like this. X is taking the values like that. So we say that here x is approaching to 0 from left. In this case we say that x is approaching to 0 from right. So in this case, what is the function value? 2. This is called right hand limit of f of x as x tends to 0. So if you observe, these two limits are not equal. Are these two limits equal? Here is 2, 1, here is 2. Both are not equal. So we say that as x tends to 0 minus limit f of x is not equal to as x tends to 0 plus limit f of x. Both are not equal. In this case we say that limit x tends to 0 f of x does not exist. So both are equal, then we say that limit of that function exists, and this limit value is said to be the limit of that function. Understood this point, my children? Right. Once go through the textbook, page number 281 to page number 291 in the textbook, to understand the concept of limit of a function at a point. Okay, my children. Now we continue the next concept in the next class. Okay, my children. Right. In the meantime, please read the textbook from page number 181, 281 to 291. 10 pages. Okay, my children. 281 to 291 in the textbook. Okay, my children. Right.